Number 10. A fundraising dinner was held on 2 consecutive nights. On the first night, 100 adult tickets and 175 children's tickets were sold for a total of $937.50. On the second night, 200 adult tickets and 316 children's tickets were sold for a total of $1,790. What was the price for a children's ticket? So I can set up a system of equations to solve this problem. Now, when I read it, they only ask me what was the price for a children's ticket. So I know I'll need a variable for children's ticket. Maybe I'll use C and say that that represents children's ticket price. But I also know that there were adult tickets sold. So I will need another variable, and maybe I'll say A is adult ticket price. Now I should be able to go back and read my problem and set up 2 equations to model the situation. So when I go back and read, I see that on the first night, 100 adult tickets and 175 children's tickets were sold for a total of $937.50. I should be able to write an equation to model that first night by writing 100 times A, which is the price of an adult ticket, plus 175 times C, which is the price of a children's ticket. And I know that if I add all the money they made from adult tickets and children's tickets, it should equal the money that they brought in, which was a total of $937.50. Now I should be able to do the same process for the second night when they tell me 200 adult tickets and 316 children's tickets were sold for a total of $1,790. So if I go ahead and write that equation, I would have 200 times the number or the price of adult tickets plus 316 times C, the price of children's tickets, and that should equal the total amount they made of $1,790. Now I have my system of equations, and I just have to choose a method for solving it. So if I think of my 3 methods and look at my equations, graphing might be a little tricky with these numbers. Substitution, well, I can get a variable by itself, but that might create some tough work. Elimination, though, looks kind of enticing to me, because when I look at the A terms, I notice that while they don't eliminate the way they are, if I take my first equation and I multiply that A term by -2, that's going to create -200A, which will eliminate the positive 200A below it. So I just need to make sure I distribute -2 to every term in this equation, and I should be able to use the elimination method. So I know -2 times 100 would be -200A. -2 times 175 would be -350C. And -2 times $937.50 would be $1,875. Now I did that math pretty quickly because I have a calculator right next to me. You guys should obviously use a calculator for doing this math. If you want to do it on paper, great. Not necessary though. Now I should be able to add all my like terms together, and those A terms should eliminate. 200 minus 200, no more A's. Now I have 316 minus 350, which tells me I have negative 34C equals, and then I'm going to do 1,790 minus 1,875, and that will give me negative 85. Now I should be able to divide by negative 34. And I know a negative divided by a negative is a positive, and 85 divided by 34 gives me 2.5. Now I know that C represents a children's ticket price, and when I write a price like money, I need 2 decimal places. So I found the children's ticket price to be not 2.5 but $2.50. Now, when I look at the question, all they wanted me to do was find the price for a children's ticket. I don't even need to go back and find A, the adult ticket price. I now know the answer to this problem. It's $2.50